All right, in this video here, we're going to go over evaluating, okay? Finding particular values or general equations where we see fit. Okay, so here in 2011, we're going to take care of part A here. Usually how it's set up is you want to make sure that you have all of your information. So usually they might introduce an equation and then a graph that represents something else. Usually that's how it's set up. Okay. So here we go. We know that g of x is 2x plus the integral from 0 to x of f of t dt. Now, I'll get this out of the way. A lot of people talk about t, like what the heck is t? T is really nothing. It's a placeholder. We call it a dummy variable, right? It's just there because we can't use the same x. Okay, so they're just using any other variable because eventually it'll disappear anyways. It's a placeholder, okay? So it has very little significance. Okay, so check it out. We want g of -3. So what we do naturally is we plug in -3 for x. Okay, so wherever you see an x, you plug in -3. Okay, so I have to address this first. You can't just plug this in and call it equal is equal, okay? Because the reason why is there's still calculus left right there. There's still an integration, okay? But once we take care of that, then we can apply the whole equal is equal bit, okay? So here we go. I know that this is 2 times -3. I know it's -6, but I'm too stingy about it. I'm not even going to simplify that, all right? Unless I need to later. The issue here is how do we take care of this, right? Notice how we have the graph of f. What does it mean to integrate the graph of f? Press play when you're ready. When you're integrating, you're really finding the area under the curve. So in this case, from 0 to -3. That looks a little bit weird because the bounds are backwards. So what I'm going to do here is I'm going to go ahead and put it back to normal because the smaller numbers should be at the bottom. So remember, you can flip your bounds as long as you account for a negative, okay? All right, so here I have 2 times -3 minus something. So I need to find the area from -3 to 0. I need to find the area from -3 to 0. So let's take a look at this picture. From -3, it starts right here. I'm trying to find the area from -3 all the way to 0. Now, most people freak out because they don't give us an equation. But if you read it, it says the graph of f consists of 2 quarter circles. That's a quarter circle right here, and here's the bigger quarter circle. Thankfully, this is the most common curvy function that we know. It's the circle. The area of a circle is really just pi r squared. But how do you find the area of a quarter of a circle? We would just have to divide it by 4. So from here, you could really just count the radius. 1, 2, 3. Looks like the radius is 3. So the area there is really just pi 3 squared over 4. Oftentimes, they'll give you geometric shapes that you've learned in geometry, okay? And from here, equal is equal because that is just evaluating. And that is really where you guys will see the advantages of that concept, not simplifying, okay? But again, you can't just leave the integral there and say equal is equal. You have to do all the calculus first, okay? So that's the first part. They ask you for g of -3, okay? And then they ask you for g prime of x, okay? So g prime of x is really just the derivative. So the derivative of 2x is just 2. And remember, the derivative of an integral will cancel out, right? That's the fundamental theorem of calculus. When you take the derivative of an integral, they kind of cancel out, and you're just left with plus f of x. Okay? And then they ask you to evaluate g prime of negative 3. So I plug in negative 3. Well, how am I going to find f of negative 3? Okay? Think about if they provided us that value, okay? Press play when you're ready. F of negative 3 can be found on the graph of f, okay? So in this picture, it actually is f. So at negative 3, you're right here. The y value is 0. So that's really just 2 plus 0. I know that 2 plus 0 is 2, but again, why do the extra work if you don't need to? Equals equal there, okay? So pause here. Think about how many points they would allot for part A. Press play when you're ready. I think it's 3 points. It's been a while since I've seen this, but I'm thinking 1 point for each section here, okay? G of negative 3, g prime of x, and g prime of negative 3. So let's take a look at 2011. There you go. It's very straightforward. So they give you a point for g of negative 3, g prime of x, and g prime of negative 3. Notice how their answers do not visibly look like ours. But again, equal is equal, and that's all that matters. Okay? There's your bare minimum, right? Getting 3 points is easy, all right? You just got to look for it. You got to find it. It's there. Okay? Cool. Let's do a couple more because there are different ones. It's not always equipped like that. So here's one that's a little bit different where they ask you to find the function. 2011 Form B, Part C. Given that f of 1 is equal to 2, determine the function f. Okay, so you can do this in many different ways, all right? I want you to notice that in that problem, they give us f prime of x. If you skim through it, right here, they give us the derivative. F prime of x is 4 minus x times x to the negative 3. So how do we go from the derivative to the original function? Because that's what they're asking us for. How do we find f, right? So the only way to do that is we have to go backwards. We have to integrate, okay? So here's what we're going to do. Let's go ahead and integrate this. So we're going to integrate 4 minus x times x to the negative 3. Okay? How would you integrate that? Okay, this one is kind of gross, but actually not that bad. So a lot of people think that this is u substitution, but remember, you only use u substitution generally when there's a function inside of another function. They wrote this one here to really make you work for the problem. This one, it would be more beneficial if you distributed the x to the negative 3 first. So 4 times x to the negative 3 is 4x to the negative 3. Okay? Negative x times x to the negative 3, if you remember power laws of exponents, you're just adding your exponents here. So here, there's like that invisible 1. So 1 plus the negative 3, that'll give you x to the negative 2. Okay? If you're not quite sure how I got that, pause, shoot me a text right now, okay? All right, so this is really easy to integrate. Go ahead and do that and press play. Okay, this is really 4x to the negative 2. Remember, you have to add 1, okay? over the same power minus x to the negative 1 over the same power. And don't forget your plus c, because there were no bounds here, okay? So this right here is f of x, all right? So we're almost there, but the c is kind of in the way. So before I do that, just to make sure that the evaluating is good, I'm going to actually clean this one up. So you kind of have to determine that for yourself, what's easiest, okay? This right here, 4 divided by negative 2 is negative 2. And x to the negative 2 will go down below because there's a negative exponent, okay? This negative and this negative here will make a positive 1. And x to the negative 1 will go down below. This is just to make sure that when I do plug in my condition, I'll be able to evaluate easily. So notice how it says, given that f of 1 is 2, determine the function f. So what I'm going to do is I'm going to plug in 1 for x. So f of 1 is equal to negative 2 over 1 squared plus 1 over 1 plus c. I know that f of 1 is 2. And this all cleans up to negative 2 plus 1 plus c. Go ahead and solve for c real quick. Press play when you're ready. So c should come out to 3 if I did that right. Okay? So now that you know what c is, determine the function. So f will be negative 2 over x squared plus 1 over x plus the 3. And there you have it. Okay, a little bit of work. So this one was focusing a lot on your analytical skills, right? Just knowing how to integrate. How many points does that offer? I want to say 2 or 3. But that's just my guess. Here we go. 2011B. And you want to guess 2, okay? Oh, it's a 3-point question. There goes your minimum one more time. You get 1 point for the integral, which is basically this here. And then they give you 1 point for knowing how to integrate, which is everything on the inside here. And then 1 point for the answer. Now, some of you are probably asking, what the heck did they do in the scoring guidelines? Okay, so instead of finding C, they did kind of what you would see in the accumulation and particle motion problem. So the alternative way is doing this, okay? It's not that much different from what we've been doing. But basically, we're going to integrate 4 minus x times x to negative 3. And down below, you're going to put down what you're given. So in this case, our given condition was f of 1. So I'm going to put 1 here. And what you want is an x, all right? Now, because x has to be here, these will change to t's, okay? So if you're given 1, you have to think about where you started. F of 1 here is 2. I'm going to leave that up to you on what makes more sense, okay? Either way is fine. It's just a matter of preference here. Which one's easier for you? Notice how they kept their answers in negative exponents. We didn't. Again, it's all preference. As long as it's equal, you guys are good. All right? But it is a 3-point question, so that's your bare minimum there. All right? Let me see if there's anything else that we should go over before I conclude. Okay, let's do this one. This one's gross. But here we go. By gross, I mean not difficult. It's just, it takes a lot of time. All right? Okay, so we're doing 2009 here. In part B, they're asking us to find f of negative 4. And then f of 4. I'll space it out. Hopefully that's enough room. Okay. So what do they give us? I noticed that they tell us that there's a piecewise function f prime of x, and the graph is the derivative. But where the heck is f? Right? So it goes back to that whole idea. Here we go. To go from f prime back to f, there has to be some type of integration. Okay? So this is the alternative approach. That plus c that we did in the previous problem works, but it doesn't always work because it kind of depends on what information they give you. Okay? So here, we're going to set it up like an accumulation problem. Okay? So check it out. We're going to go ahead and integrate f prime. Okay? What we want is negative 4, right? I'll write want. What we want needs to go upstairs, so negative 4 goes here. Okay? What we're given goes down here. So can you guys tell what is given? You got to read through the text here. But press play when you're ready. What's given is actually right here. They always give you one type of point. Okay? So in this case, it's 0, f of 0. So I'm going to put in 0 here. But then you got to consider what you start with. So this is f of 0. Okay? So what I want you to do is I want you to practice here for f of 4. Think about how f of 4 would be set up before we actually take care of each. Okay, so again, it's the integral. We're going to integrate f prime of x. What I want is 4, so I'm going to put 4 at the top. What I'm given is still 0, so I have to consider what I start with, which is f of 0. Not that bad, right? Again, this is accumulation. You have to consider where you started and how much you have accumulated. All right? Okay, how do we actually do the problem? I'm going to erase this here so we have a little bit of space. Each problem is going to be dealt with differently because of what you're given. So let me take a look real quick to... okay, let's do the first one, okay? F prime of x is split up into a piecewise function. So from negative 4 to 0, they have this g of x function. What the heck is that, right? After 0, from 0 to 4, they actually explicitly give us a function right here. Okay? So if you read, g of x is a semicircle. Right here, you see the semicircle? So, semicircle is a common shape in geometry that we can easily find the area of. This one here takes a little bit of thought. Here we go. I noticed right away, let's take care of the easy parts. I know that f of 0, my arrows, f of 0 is definitely 5 because that's what's given. I noticed that the bounds here are a little bit backwards, so I'll go ahead and instinctively switch it, but account for a negative. Okay? I know that when I'm integrating f prime of x from negative 4 to 0, that's really just integrating g, because from negative 4 to 0, I'm really just focusing on g here. Now that step really wasn't necessary, but I wrote it there so you guys can see what I'm talking about, okay? Okay, so this is going to be 5 minus the area under the curve from negative 4 to 0, okay? So now let's take a look at the graph. From negative 4 to 0, negative 4 is right here, okay? We're finding the area from negative 4 all the way to 0. Okay, You really got to think about this here. How would you find the area knowing that that shape is a semicircle? Press play when you're ready, okay? So when you're finding the area of the semicircle, that would give you this in orange, right? That's the semicircle, but that's not what you want. You want the green stuff, okay? So what you do, if I could illustrate this, if you combine the orange and the green, it makes a perfect rectangle, which you know you can find the area of. What we're going to do is we're going to find the area of this rectangle here. And then we're going to subtract out that semicircle. And if I do that, I'll get everything in green. Okay? Make sure that that makes sense to you. That does pop up occasionally. The concept of subtracting out area, you want to make sure that you can handle that, okay? All right, so here we go. If I'm looking at the red rectangle, the rectangle has a base of 4 and a height of 2. So base times height is 8. But again, I'm just going to write 4 times 2. And I'm going to subtract out the area of the semicircle. So the semicircle has a radius of 2. It looks like there's a radius of 2 here, okay? So that's just pi 2 squared. That's the area of a circle. If I want a semicircle, I have to divide that by 2. Okay? A lot of analysis, not really too much for work, but there you go, equal is equal. We can leave it right there, okay? Now, f of 4, since we're finding the area from 0 to 4, notice how this curve is not anything common, right? Actually, that's why they gave us this right here, 5e to the negative x over 3 minus 3, when we're going from 0 to 4. So we have to solve this analytically. So here we go. F of 0 is still 5 plus whatever the integral of that is, right? So the integral from 0 to 4 of 5e to the negative x over 3 minus 3 dx. So here they're really assessing you on your analytical skills. Okay? I'm going to go ahead and rewrite it so that you guys can see it. For instance, that 5 next to the e can bump outside. Okay? And that minus 3 can be separate. Okay? That way it's a little bit easier to see. I know that this here is 5. This over here is just minus 3x from 0 to 4. Okay, so the integral of a constant is just something linear. So the part here is you got to take care of that. Okay, it's a little bit of u substitution there. Take care of it, and then let me know what you get. Okay, so this is going to be 5. We're going to go ahead and let u equal negative x over 3. So du would be negative 1/3 dx. So dx would be negative 3 du. I know I went through that very quickly, but if you need help with that, please do let me know. So I know a negative 3 is going to be on the outside. Okay. This will be e to the u du. I'll just put stars here because I'm going to go back to x's anyways. So that'll be 5 minus 15 e to the negative x over 3 minus 3x. Hold up. My brackets are off. Let me do plus negative, so it's a little bit more logical, from 0 to 4. Okay? So a little bit of work here, but here's the nice part. there's really only one more step, applying the fundamental theorem of calculus. After you integrate, you plug in your upper minus your lower. So here we go. 5 plus upper will be negative 15e to the negative 4/3 minus 3 times 4. Let me go ahead and group that. Minus negative 15e to the negative 0/3 minus 3 times 0. Although that's a lot, you could actually stop there because equal is equal. You did all your calculus. Okay? A little bit of work, right? But doable with practice. If you take a look at the point system, here we go, 2009. So although that was a little bit of work, check that out. That was a 5-point question, right? You get a point for setting up the integral, just setting it up, okay? And a second point for the answer. So even if you couldn't integrate that, just the setup, you would get 1 point, okay? And the second part, same thing. Setting it up gets you a point. Finding the actual antiderivatives gets you another point. Plugging in your upper and your lower will give you a third point. Although this takes a little bit of time, it pays off, right? 5 points out of 9. Way more than what you would need for that AP3, right? You need a bare minimum of 3. So anything extra is just a bonus, right? So there you have it. Although it takes a little bit of time, it pays off. So really be precise and accurate when you're going through those problems there, okay? Is there anything else I need to go over? Let me take one last look. Yeah, I think that's good. Try the rest, and if you get stuck, just let me know.